In this example, we're going to solve this system of linear equations, and it has 3 equations and 3 unknown values. And we're going to do so by making substitution our first step. So I notice that the t variable in the first equation has a coefficient of -1, so that t will be easy to isolate, and we will have an equivalent expression then that we can use for our substitution. So I'm going to take this negative t and I'm going to push him over here to the right side and make him a positive t, while taking this positive 20 and moving him to the left to make him a negative 20. So I have negative 3r minus 6s minus 20 equals t. So here is our equivalent expression, this negative 3r minus 6s minus 20. So since I know that's equivalent to t, I'm going to go ahead and substitute this expression into the t in both the second and the third equations. Okay, so the second equation looks like negative 5r minus 2s minus 4t, and then the equivalent expression is what I will substitute in here for t, and then that business equals 0. So let's go ahead and distribute and kind of simplify this a bit. So negative 5r minus 2s plus 12r plus 24s and plus 80 equals 0. So I want to write this kind of in standard form where I have the r and the s on the left side together and then the constant over on the right side. So negative 5r and positive 12r will make 7r. Negative 2s plus 24s will be plus 22s, and that will equal a negative 80. So here is one of my equations that I'm going to use. Okay, let's go ahead and take this equivalent expression, and once again we'll plug it in, and this time we're going to do it for t in the third equation. So let's go ahead and write this third equation down. Negative 5r plus 5s plus 3t, and of course t then is this equivalent expression, and that equals 7. So let's move this down a little so we have some room to work. So negative 5r plus 5s minus 9r minus 18s minus 60 equals 7. So let's go ahead once again, put it in standard form with kind of the r and the s on the left side and then my constant on the right side, so it'll be in the same form as this other equation. So I have negative 14r and then 5s and negative 18s will be negative 13s, and that's going to equal 67. So here I have 2 equations. I'm going to go ahead and kind of keep these handy. I'm going to rewrite them up over here where I've got a little more room. So I'm going to have 7r plus 22s equals negative 80, and negative 14r minus 13s equals 67. Now it looks like elimination is going to be a really good choice here because the r's, 7 and 14, the coefficients, well, 7 is a factor of 14, so I know if I multiply the top equation by 2, 2 times 7 is positive 14, and then this negative 14, so when I add the 2 equations together, the r's will eliminate. Let's go ahead and run this 2 through. So 14r plus 44s equals negative 160. I'm going to go ahead and write this other equation. It's left unchanged. So now let's add these 2 equations together. My r's cancel, which was the point of that. So I have 31s equals a negative 93 when I take negative 160 and add 67. So when I divide both sides by 31, s equals negative 3. Okay, so now I have one value for my 3 variables. So I have the s, but I still need the r and the t. So let's go ahead and take this s and plug it into either one of these equations because these 2 are limited because they only have an r and an s. So if I know the s, then I can go ahead and solve for r. So let's go ahead and do that. We'll bring that down here. I'm going to say 7r plus 22s, and my s is -3, and that equals -80. So 7r minus 66 equals -80. When I add 66 to both sides, I get -14. And a quick division by 7 will give me r equals -2. So now I have 2 of the values for my 3 variables. So I have r and s. So now I'm only required to find t, and then I'll have all 3 values. So where should we plug these in to find the value of t? Well, we've already done the work here, and we know that we have an equivalent expression for t. T equals this expression right here that we were plugging in earlier. So let's say then t equals -3r minus 6s minus 20. So t equals -3 times my r value, which is -2, minus 6 times my s value, which is -3, and then minus 20. So t equals 6 plus 18 minus 20. So it looks like t equals 4. So now I have values for all 3 variables, r, s, and t. So I'm going to write my solution then as an ordered triplet. And the big thing is make sure your variables are in alphabetical order. So it will be r, s, t. So -2, -3, 4. And this ordered pair now represents the solution to this initial system of equations with 3 variables and 3 unknowns.